Similar to the series FIR, there is a function called series IIR. IIR stands for Infinite Impulse Response. Like FIR, it's mostly used in signal processing. The difference is, with infinite impulse response, the array value that's passed in, we expect to go on indefinitely, as opposed to the FIR assumption that those values will be declining to 0. Like FIR, IIR does have some functionality we can use in our day-to-day operations. One of the main ones is calculating cumulative values. I'm going to go ahead and run this because it's going to make it easier to illustrate what I'm talking about. Here you can see I have an array, 10, 20, 30, 40, so forth. I've also used the range function to create a range of dates. I'm then going to use my extend, cumulative total equals, and I'll use my series IIR. The first value I pass in is my dynamic array. I then use dynamic1 to indicate I want to grab a single value from the array. So the first time through it's going to be 10, second time through 20, and so forth. The third parameter, which is the second dynamic array, has 1, -1, which says we'll take the current value and go back one position. Finally, we take all of those array outputs and use mvexpand to turn them back into rows. So if I look at the output below, what happens is, the first row, I get 10. There was no cumulative total before that, so 10 plus 0, I get 10, and that's what's placed in cumulative total. On the next row, my value is 20. So I take 20, I go to the cumulative total, go back 1, which is the value 10, and I get a value of 30. I then repeat this. The next value up is 30. So for 30, I go back 1, grab its cumulative total, and add it to get a total of 60. And again, we repeat this, and as you can see, it can make doing cumulative totals pretty darn easy. Now let's do something a little more useful. In this example, we're going to determine the number of alerts on a computer for a given day and then accumulate those alerts over time using series IIR. Like I did with FIR, I'll run this in pieces so that you can see what's going on. I'm going to start by using my alert table, filtering down to what I want, and then I'm going to use summarize to get a count for each computer where I bin this by the time of day. The next thing I'm going to do is order it by the time generated, and then I'm going to use summarize to convert the count and the date into arrays. I'm then going to use my series IIR to do the cumulative alert calculations. Over in the output, you can see that my first count was 1, which gives me 1.0 in the cumulative account. My second one was also a 1, which I add to the original count, and I get 2.0, and that goes on and on. We'll then use mvexpand to convert these arrays back into rows. I'm going to extend to take the alert date and use format date time to format something a little nicer to read. I think we can all agree that 2018-0310T0000 is a little harder to read compared to just 2018-0310. Then finally, I'm going to use project to project the columns that I want and rename them to something a little nicer to read. With a slight variation to our query, we can actually render this as a chart. The big thing we have to do down here in the extend is convert this to data types our chart likes to have. It likes to make sure that things are in a date time format and that our counts are typically in integers. It likes to use integers when rendering. And if you look down in the cumulative alert column, you're going to see 1.0, 2.0, 3.0, and so forth, indicating that those are not ints, but what it considers to be real or decimal type data. So once I have that, I can just project the two columns that I need for my time chart and display the time chart below.